This podcast is supported by Progressive. On average, customers who switch to Progressive save $668 a year on car insurance. Start a quote online and start saving today at Progressive.com.
Welcome to Stuff to Blow Your Mind from HowStuffWorks.com.
Hey, welcome to Stuff to Blow Your Mind. My name is Robert Lamb.
And I'm Joe McCormick. And Robert, I've got a question for you today.
Hit me.
In your opinion, what is the creepiest image photograph produced by human space exploration?
Well, since we're talking about exploration, I imagine this rules out weapons tests.
No. I'm not interested in nuclear bombs.
Yeah, because we have some pretty creepy nuke test footage, such as 1960s Operation Dominique, which involved atmospheric sort of / space detonation of nukes.
Oh, I don't think I've ever seen that.
Oh, yeah. It's, for instance, there was the Starfish Prime event in which a 1.4 megaton bomb detonated 250 miles or 402 kilometers above the planet. And that's above the Kármán line. So that's pretty disturbing when you think about it, like a Cold War space detonation test. But as far as like pure space exploration goes, I'm always a sucker for stuff like the so-called Martian face, or even something like the hexagon of Saturn. Something that just inspires this sense of mystery where you're asking like, what is this place really?
Oh, the hexagon on I believe it's the North Pole of Saturn. It's either the North or the South Pole. I can't recall.
I believe it's North. We talked about it in one of our previous episodes.
A haunted geography and a haunted geometry.
Very Lovecraftian.
Yeah, I guess there are forbidden geometries all through the Lovecraft cosmos, right?
You know it.
But I've got a different answer. And for a long time, this has been my answer. My favorite creepy space images have got to be the photos taken by the Venera 13 lander. Robert, I've got them in the notes here, but had you ever looked at these before?
Yes. I'm not sure I'd seen the color-corrected ones, but certainly I'd seen the other ones that have that deep kind of reddish-orange tinge to them.
Yeah, it's funny to try to explain what's disturbing about them because they're just pictures of some rocks. It's just you're looking at some rocks and soil. Now, what the Venera landers were, it was a series of space missions to the planet Venus that was done by the Soviet space program. They launched these missions to put landers down on the surface of Venus for the first time. There hadn't been landers sending things back from Venus or the surface of Venus before this, but they sent a bunch of missions in the 70s and the 80s. And one of the things about landing on Venus, and we'll definitely get more into this in the episode, is that you've got a very short window of time to send stuff back because Venus is a death trap.
Yeah, it will destroy you.
Yeah, even for highly shielded, powerful machines. You put a machine down there and it's a suicide mission. The machine's going to gather some data and transmit as long as it can, but eventually the crushing heat and pressure of the atmosphere of Venus will kill that robot, and it will only have this last sort of death note to send back to Earth. And one of these missions managed to send some really striking pictures as that last death note. Specifically, it was the Venera 13 lander, which was launched on October 30th, 1981, and it landed on Venus on March 1st, 1982. So even the idea of a lander setting down on Venus, if you know anything about the Venusian atmosphere, is kind of creepy to imagine because first you're going into this haze of sulfurous clouds, but as you go further and further down, the atmospheric pressure gets so much and so dense and so thick that it's almost more like sinking into a liquid.
Yeah.
And so you got to imagine this lander sinking down into this atmospheric ocean surrounding Venus, this boiling hot, lead-melting atmospheric ocean of carbon dioxide and nitrogen with all this sulfur everywhere. And then finally it sets down on the surface and takes these images and sends them back to Earth. And there's almost nothing in the images. You just see the edge of the lander in the foreground, and it has some appropriately creepy-looking triangular teeth all around it. And then beyond that, there's some soil and some flat rocks. But nevertheless, something about these images messes with me. I find them absolutely creepy and haunting. They have this dirty grindhouse kind of yellow film effect to them. And that's, of course, the atmospheric effects that we see from the glow of Venus. It's almost as if we're looking at everything through an evil haze.
For me, I think it's because it's like the last known photograph from the very borders of the known world.
Yeah.
It's like if somebody went to the Texas Chainsaw Massacre house and took a picture of their feet by accident, and then that's all you had to go on.
Right.
You know something terrible happened afterwards. You don't have a lot of details, but you have this picture of somebody's feet on a front porch in Texas.
That's exactly right. Yeah, it feels like that. And another creepy thing about them is that you notice a difference that unlike Mars, where if you see images back from the surface of Mars, they can sometimes look kind of creepy, but it can also just look kind of like, a desert on kind of an overcast day with just a very barren area with sand and rocks and kind of a gray-white sky. But unlike on Mars, one thing you'll notice is the effects of sunlight and the directionality of the sunlight, where if there's a thing sticking out of the rover, you can see it casting a shadow on the ground. These pictures have no indication of shadows, really.
Looking at them again as we podcast here, I do think there is a sense of one taking a picture of one's own feet here. So there's an incompleteness to it. It's that just gets at you. Whereas at least with the Mars images, we have more of a true, panoramic vision of what's going on there.
Well, Mars has been thoroughly explored on the surface at this point. I mean, we have all kinds of pictures of what Mars looks like at different times of day, different times of the year, from multiple different landers and rovers. Mars almost feels like, I don't mean to poo-poo Mars. I mean, Mars is still fascinating and mysterious and wonderful, but it's very much more explored territory at this point.
Yeah, we know, as we've mentioned before, we have more detailed information about the surface of Mars than we have about the bottom of the ocean.
In some ways, that is definitely true. But the surface of Venus is like, it's this mystery hell, it's this hazy mystery that's beyond the gate. And because it feels like this hazy mystery that's beyond the gate, for some reason the idea of life on Venus has always seemed more creepy and interesting and tantalizing a possibility to me than the idea of life on Mars. I don't know if you feel the same way.
Yeah, I definitely think so. I think it's kind of a shame that Venus doesn't get more attention, especially in terms of our science fiction. Because when you think of life on another planet within our solar system, you think of really the rich history of imagining life on Mars, both in the future and the past. Because you have everything from, of course, the old Edgar Rice Burroughs novels to Total Recall. I mean, you have there's so much great stuff there. But when you start looking for really cool examples of life on Venus, there are some great examples, but there aren't as many. It's not the place that the human imagination instantly goes to. But as we'll discuss in this episode, we really should, because there are some strong cases to be made for life on Venus, either now or in the past.
Yeah, and so that's going to be the main subject of today's episode. If there are, or if there have been creatures of Venus, what are they like, and how would we know about them?
Now, if we just turn to fiction for a few examples, we don't have time to catalog everything, but I wanted to mention a few that came to my mind anyway. There is an H.P. Lovecraft story from 1939 that he wrote with Kenneth Sterling titled In the Walls of Eryx, which features a muddy jungle Venus and a maze with invisible walls.
Oh, that feels about right.
Yeah. It's pretty good. I remember digging that story when I read it. C.S. Lewis took us to a Venusian paradise in his novel Perelandra. This involves an alien, Adam and Eve, and then of course you have the devil show up as well, possessing the body of a character by the name of Professor Weston.
Professor Weston. I wonder if that's named after Jesse Weston, who wrote the book about the Grail legend that was so popular in the early 20th century.
I don't remember, But it's Perelandra was a book I really loved when I was younger, and we'll probably read again at some point.
Oh, I've never read it, but that seems interesting to explore, especially because you've got multiple mythic associations with Venus throughout history. You've got the god of love and the Eros and the Venus Aphrodite kind of association, but you've also got the Lucifer association.
Yeah, and both are explored in Perelandra. In Perelandra, Venus is also a water world.
Oh.
And they're like these kind of floating rafts of land land that everyone is, everyone, it's like 3 or 4 people, 3 or 4 individuals anyway that live there. But yeah, it is an interesting take on Venus as well. Stephen King took us to Venus twice, as it turns out. Once in a 1960s self-published short story titled The Cursed Expedition, which I have not read. I'm not sure that's one that's actually readily available, or it's kind of like a vault story of King's. And then there's, of course, his 1971 short story, I Am the Doorway, which doesn't actually visit the planet, but a character takes part in a manned Venus flyby and comes back essentially infected with an alien organism.
Well, it's interesting to think about that this is a time period at which the Venera missions were underway.
Yeah. There's also a similar Outer Limits episode from 1964 titled Cold Hands, Warm Heart that actually stars William Shatner.
Oh, what?
Yeah.
So Shat goes to Venus, or he's from Venus, or what?
I haven't seen this episode, but he is involved in some sort of space mission involving Venus.
Okay.
Yes.
So you can't give me the deets on the Shat.
I mean, things go, weird. That's again, this is not an Outer Limits episode that I've seen, but perhaps we have listeners who can chime in on it. And then, of course, Venus plays an important role in The Expanse, TV series adaptation of the novels. No spoilers, but it does have a pretty cool plot line involving life and Venus. And there's also early mention in the books and perhaps the TV series as well about a failed attempt by humans to establish cloud colonies there.
Oh, yeah, that is an interesting idea I've read about, the idea of trying to create I don't know whether you call them aerostatic or hydrostatic, basically floating colonies that would be not too hard to do, actually, because of how dense the atmosphere is.
Yeah, it's a cloud city right out of Empire.
Yeah.
Yeah,
except, I don't know, Bespin didn't look all that cloudy compared to Venus.
Yeah, well, I mean, they were up there, right?
Yeah.
It's been a long time since I've seen Empire, so I don't remember how cloudy it was. Or if it became more cloudy in the special editions that came out. Who knows?
Oh, yeah, they really CG'd some more clouds in there. It was worth it. No, I think it's interesting that Venus doesn't get as much attention as Mars does in terms of the possibility of finding microbial life forms. I mean, way back in the day, people used to think before we'd explored Mars that there might be whole civilizations there. People would look through telescopes and see what looked like canals on Mars, and they'd say, oh, there are people on Mars just like there are people here. Now we pretty much can rule that out.
I wonder if part of it is because we went from being so geocentric, the idea that the Earth is the center of all things, and then we went to a heliocentric model, and then, of course, we expanded beyond that. But if we're still kind of thinking heliocentrically, so the sun is the center of our solar system, and therefore it's kind of a center of order and the known, and this is not something that actually matches up necessarily with our scientific understanding of everything. But it is a center, and therefore Venus is closer to the center. It's closer to the center of the known, whereas Mars is a little beyond us. Like Mars is a little more on the outskirts, and therefore it makes more sense that it would have more mystery to it. That's where the ghosts and goblins are going to live, right? They're not going to live in the middle of the city. They're going to live on the outskirts of town.
Well, yeah, it's the outer limits. You don't talk about the inner limits.
The inner limits.
Though I do really enjoy science fiction that goes inward instead of goes outward, actually. I mean, this is something I really liked about that movie Sunshine that came out.
Oh, yeah?
Which, had a lot of problems. I think some of the writing kind of fell apart in the third part of the movie. But it explored the idea that there was this deep kind of ghostly mystery to the sun, and as you come closer and closer to the sun, it sort of activates these instincts within you that are sort of borderline supernatural, but at least seem to go deeper than the human or mammalian parts of your nervous system. Where the sun is the closest thing to a literal god there is in the physical universe, right? It's the creator of us.
Yeah, I think that, coupled with the fact that humans just want to keep going out. It's one of the reasons probably that more people have been to the moon than to the bottom of into the deepest portions of the ocean.
Well, I think we should ignore this impulse to go out and we should go in. Let's go in toward Venus, get closer to the sun, move one orbit in, and start looking at this hothouse planet.
Yeah, why go to a planet that doesn't have enough atmosphere when instead you can take your dreams and your imagination to a place that has more atmosphere than you can handle?
Let's take a quick break, and when we come back, we will explore the surface of Venus.
When you're hiring, you don't want to waste time. You want an efficient way to get to your short list of qualified candidates. That's why you need Indeed.com, used by over 3 million businesses. Post a job in minutes, set up screener questions, then zero in on qualified candidates using an intuitive online dashboard.
And when you need to hire fast, accelerate your results with sponsored jobs. New users can try for free at Indeed.com/stuff. That's Indeed.com/stuff. Terms, conditions, and quality standards apply. All right, we're back. Now, you're probably familiar with some of the most basic features of Venus as a planet, right? That it's very much known as an Earth analog, and that is a fair way to characterize it. It's very close to the size and mass of the Earth. It's going to, it was created around the same time in the accretion disk of the inner rocky planets. So in many ways, it is a lot like the Earth until you get down into the atmosphere. So, Robert, can you take me on a tour of the surface of Venus?
Yeah, I actually chatted with astrobiologist David Grinspoon about the surface of Venus several years back, as well as with JPL scientist Suzanne Smrekar. So I want to run through some of the attributes of the planet here that they stress to me.
All right, let's take a stroll through the toxic soup.
All right, so Grinspoon pointed out that, first and foremost, this is a planet that's very rich in volcanoes and mountains and tectonic features. Mm-hmm. Now, not to be confused with tectonic activity. We'll get back to that. You won't find signs of water erosion, probably, unless they're very, very ancient. And a lot of the topography is dominated by a sort of low-lying rolling plains that are largely ash. And this is punctuated by some high volcanic mountains and some other sort of high plateaus of titanically disrupted areas with flows of ash.
So this is a planet surface that has been sort of like hit and paved by volcanic activity.
Yes, yeah. Also, he says there's seemingly steady, slow winds always blowing east to west, and as we've already touched on, the atmospheric pressure is very high.
Now, one interesting thing about the directionality of the movement of the atmosphere there is that Venus rotates opposite of the way that most of the planets in our solar system rotate. It rotates in a retrograde way to its orbit, so the sun actually rises in the west and sets in the east on Venus.
Yeah, it's interesting. It also has an extremely slow rotation, 243 terrestrial days. That's how long it takes. But its atmosphere only needs 4 days to rotate.
Okay. So,
yeah, there's already, you can tell there's a lot of from a terrestrial standpoint, a lot of screwy things going on with Venus. Mm-hmm. If you were this is like approaching the Texas Chainsaw Massacre house and finding all sorts of bone-based, voodoo doodads hanging in trees and bushes.
Right, some skull furniture.
Yeah. So the pressure is high, roughly 90 times the pressure at sea level on Earth.
That's a lot of pressure.
Yeah, of course it's going to vary, though, depending on exactly what altitude you're at on Venus. We've already touched on the light a little bit. You'd find very dull light. Grinspoon says that if you were suddenly transported to Venus, you would notice that the light is very different. It's always cloudy, and there's a very thick the very thick atmosphere. So light he says is kind of diffused and gathered. So much that it's kind of reddish. And there are, as you said, no shadows because there's no direct sunlight. It's all just clouds and scattered light. He says that there would be enough daylight to see, but it would be like a heavily overcast day on Earth. And of course, on the night side, it would be dark, aside from whatever kind of like you would probably notice the dull red glow of the red hot rocks in the ground lighting things a bit.
Creepy.
And he pointed out that it is pretty much Earth's alter ego. It's the only Earth-sized planet in our solar system, the only other roughly Earth-sized planet that we can send a spacecraft to and study in detail. And that's going to be true for a long, long time. Mm-hmm. And indeed, Earth and Venus probably had similar origins. It could have been they could have been in nearly identical states in the beginning, and yet we have gone down very different routes in terms of how our climates and surface conditions have turned out.
So yeah, if we started in similar states, what happened to Venus to make it so different from us?
Well, runaway greenhouse effect. boiled away the oceans long ago, and they were lost to space, and then it became essentially stuck with its present climate. It's often touted as kind of a worst-case example of what climate change on Earth could amount to.
Yeah. Now, you might have heard of this idea of the runaway greenhouse effect invoked, but if you're wondering exactly how that works, basically what happens is you've got some liquid on the surface of your planet. You've got, like, say, liquid water oceans. And if you heat the oceans up too much, they begin to evaporate a lot of water vapor into the atmosphere. But of course, water vapor is an excellent greenhouse gas. And then when there's a lot of water vapor in the atmosphere, because it's a greenhouse gas, sunlight can pass through it one way, coming in to heat the Earth or heat the planet, but then it does not allow as much energy to reflect back off of the planet and radiate back out into space. So like other greenhouse gases, this water vapor lets energy in but not back out, and this warms the planet even more. As the planet warms, the water vapor just keeps evaporating even more because it's getting hotter and hotter, making the effect worse and worse in this net positive feedback loop. So there are sort of these tipping points for planets with liquid on the surface. You don't want to get the water hotter than a certain level, because if you do, it's just going to create this runaway effect that you kind of can't stop.
Now, I mentioned plate tectonics earlier. There are no plate tectonics that we know of on Venus, but certainly there's a lot of volcanic activity. The volcanoes, though, don't spring up along plate borders like they do on Earth. They just pop up all over. So there's
just kind of surprise volcano.
Yeah. It's a different pattern of convection, or so it seems, according to Grinspoon. Now, in addition to the greenhouse gas issue, he did drive home that a lot of the differences may also just be due to orbit. Obviously, Venus is more of an inner planet than Earth,
right.
And there are just going to be certain differences in place just on where you are in relation to the sun.
Right. So it is closer to the sun than us, but that's not the only thing that plays a role, because, for example, the surface of Venus is hotter than the surface of Mercury, which is closer to the sun than Venus is. So it definitely, the atmosphere plays a huge role in what surface conditions are like.
Right. And we already hit on the fact that the atmosphere of Venus is pretty incredible. The clouds of Venus are concentrated sulfuric acid.
Yeah. Now, that's not to say that the atmosphere is concentrated sulfuric acid. The atmosphere is about 98.5 carbon dioxide.
Right, yes.
98.5% carbon dioxide with like 3.5% nitrogen or so. And then it's got these aerosolized sulfuric acid particles, like colloidal sulfuric acid suspended in the atmosphere. Needless to say, you wouldn't want to breathe it.
Now, did we touch on exactly how hot the surface is?
I'm not sure we did. That's worth mentioning, because it's hotter than you think, Dad. Hotter than you think.
Yeah, Suzanne Smrekar pointed out that the surface temperature is around 900 degrees Fahrenheit or 482 Celsius.
That is, an often cited fact, hot enough to melt lead. These are almost like metalworks kind of conditions.
Yeah, and another cool thing that she pointed out is like, okay, assume you're on the surface. You're wearing some sort of high-tech suit that prevents you from having to worry about melting or being crushed. And she points out that walking on the surface would be really weird, because it would be like walking. It would be more like walking through a fluid than what we think of as an atmosphere.
Yeah.
And this is, again, due to that high pressure, supercritical CO2. So in some aspects of a fluid would be present, as well as some aspects of a gas.
I wonder if that atmospheric density is part of what contributes to the creepiness of those photos taken by the Venera 13 lander. I don't know. Like, is that cueing something in my eyes? Does somehow the air look wrong?
Like it looks heavier or something? Yeah.
I wonder.
Now, Smrekar also pointed out that one of the biggest mysteries about Venus is why it doesn't have plate tectonics. And she says that the planet completely resurfaced sometime in the last billion years, and so we have no record of what happened in those first 3.5 billion years.
Now, this is premised on the fact that Venus is basically the same age as the Earth, that they were created in this planetary accretion process, and both planets are about 4.5 billion years old.
But something happened about 1 billion years ago on Venus that resurfaced most of it and hid the evidence.
They were like, we got to get this redone. I'm sick of this old pattern. We got to get it repaved.
But she pointed out that we really don't know if it was some sort of catastrophic event that caused a huge amount of volcanic activity to made it occur within a relatively short period of time, or if it's just been a steady process over the last billion years where volcanic activity has just been accumulating.
Now, one of the things we often talk about when considering whether or not a planet can sustain life is what the sort of the geomagnetic properties of the planet are. Now, we know that Venus does have an iron core like Earth does, but the question is if it's going to sustain life on its surface or within its atmosphere, does it have a magnetic field to shield it from radiation coming from space?
Well, yeah, the answer here is really interesting because no, it does not have an internally generated magnetosphere. The solar wind can slam directly into the atmosphere. However, it does benefit from partial protection due to its induced magnetic field.
Now, what's that?
So you have solar ultraviolet radiation removing electrons from atoms in the upper atmosphere, creating the electrically charged gas of the ionosphere. As on Earth, it slows and diverts the flow of particles around the planet.
Oh, now that's interesting. But so far, I guess we should say we've just been sort of talking about the planet in general and kind of spitballing about what life there could be like or things that occur to us. What do the experts actually have to say about the possibility of life on Venus either in the past or now? I mean, it's hard to imagine life on the surface of Venus now given how hot and high pressure it is, but let's not prejudge the question. What would, for example, David Grinspoon have to say about life on Venus?
Well, he's very clear about the fact that there's nothing controversial at all about speculating that ancient Venus might have boasted life. Because he says if you go back 4 billion years, you'll find an environment very similar to Earth.
Yeah.
And so much of our speculations regarding life on other worlds, it centers around the question, how much like Earth is it or was it?
Yeah. Now, of course, that's premised on the fact that we basically know of one way biochemistry can work, and that has certain physical tolerances built into it. Biochemistry can work in a carbon-based way with water as a solvent, and so we know that can only happen in a place where there's the right kind of temperature to have liquid water, where it doesn't freeze or boil, and you've got the right kind of organic molecules present. So that sets these tolerances there. But then again, there are other ways we maybe aren't even imagining that biochemistry could work just based on our limited imagination.
But still, based on what we know, there's nothing wrong with saying, well, life could have existed on Venus.
Yeah, I mean, you know a place like Earth can have life.
Right. And Grinspoon says it's even conceivable that life could have begun on Venus and then we're all essentially Venusians. He points out that you have rocks being blasted between the planets, so there was contact. So some form of panspermia is possible. Concerning life on Earth and possible life on Venus.
Now, that's something people bring up as a possibility, but not to say that there's a strong reason to favor that hypothesis.
Right. Now, some of a lot of the key theories regarding life on Venus do, in the past, revolve around the idea that there may have been oceans there in the past.
Right. And we still don't have definitive proof, I think, that there were oceans on Venus in the past, but there are pretty strong reasons to think that it at least might have had oceans. I was looking at one study by Arnaud Salvador et al. From the Journal of Geophysical Research, Planets, in 2017, and this was kind of interesting. So the background on the study is that they talk about how early in the history of a solar system, you've got young inner planets and they get bombarded by lots of impacts from rocky objects orbiting the sun, right? The early solar system is very dirty and it's very full of stuff. And over long periods of time, eventually it gets kind of cleaned up. But early in the solar system, you got big rocks slamming into young planets, and they slam into them from space and can actually heat planets up a lot. And big enough impacts can even melt large portions of the mass of the planet, which surrounds it in this ocean of melted rock. But after this happens, the molten ocean cools and then releases volatile compounds to create the atmosphere. And in this study, the authors create a model where they can sort of play with model planets in this state, right? You've got model planets in early stages of formation that are releasing certain amounts of CO2 or water onto their surface, and that's affecting, whether it has oceans or what the atmosphere looks like. And so that you can place a model planet like that in orbit at different distances from a host star and then predict what kind of surface the planet will evolve in its geohistory. And their model suggests, based on what we know about Venus today, that it could have had water oceans earlier in its history. It's consistent with what they've found.
Now, the presence of some sort of an alien Adam and Eve, there's no proof for that.
Right.
You just have to leave that to C.S. Lewis.
Even though it might be hard to know for sure whether there was life on Venus a long time ago, we can at least get good clues about whether there would have been windows of opportunity for it, right?
Yeah. According to Sanjay Limaye and co-authors in a 2018 astrobiology paper, Venus could have boasted a habitable climate and liquid water for as long as 2 billion years. That's longer than it might have occurred on Mars. So you have a pretty long period of time there. That is enough time, based on our terrestrial model, for at least simple life to emerge.
Yeah. Now, if you look at that period of time on Earth, you're not really getting beyond single-celled organisms.
Yeah, I mean, to put that in perspective, 2 billion years of life on Earth was enough to get us from the deep-sea vent life to single-celled life, able to get us to photosynthesis and atmospheric oxygen. But you'd need another 1.5 billion years of Earth life to get to like multicellular life and sexual reproduction. So was there, based on the Earth model, was there life on Venus? Maybe. Was there sex on Venus? Probably not.
But maybe. Okay, imagine on Venus for some reason life evolves faster.
Yeah.
Maybe there's a faster mutation rate, something like that. By the end of this episode, I want to be imagining what it could have been like if there was fully evolved intelligent civilization on Venus that is now just paved over by volcanic activity and we can't see any trace of it.
Well, it would be a shame, wouldn't it, that the planet named for the goddess of love would have never known sexual reproduction. It was just all asexual.
That would be a cruel irony. Well, anyway, so we've been exploring this question of whether life could have existed on Venus in the past, but we should transition to talk about whether life exists on Venus today.
Yeah, because this is where we really get into the imagination capturing aspects of exploring Venus. The idea that we could send something there, some sort of probe, and discover life, like actually harness and study an example of life on another world.
Now, you're probably thinking, no, wait a second. Earlier, didn't you say that the surface of Venus had 90 times the pressure of Earth's atmosphere at the surface and was like 500 degrees Celsius or like 900 degrees Fahrenheit? So you may be thinking skeptically, you're not suggesting that life exists on the surface of Venus, or are you?
Well, not on the surface. We got to get our heads in the clouds. That's where things become more tolerable, at least in terms of modern Venus.
All right, we will explore that when we come back from this break. Hey, Robert, don't you love a good 80s action movie recruiting montage?
Oh, yeah. You just drop that sweet montage music on top of everything, and then all your desired recruitments just start popping up, right? Ready for action, each with their own specialized skill set.
Yeah, the music's pumping, and then you got your hero. He, shows up over the horizon at some dusty outback airport. There's one guy sitting there. He sees him. They nod to each other. The guy at the airport gets up and walks off, and next thing you know, they're all suiting up, grabbing their vests, their bandoliers, and they're ready to go.
Yeah, but of course we know that in real life, it doesn't really move that smoothly, and that's why we need Indeed.com. When you're hiring, you don't want to waste time. You want an efficient way to get to your short list of qualified candidates. That's why you need Indeed.com, used by over 3 million businesses. Post a job in minutes, set up screener questions, then zero in on qualified candidates using an intuitive online dashboard.
And when you need to hire fast, accelerate your results with sponsored jobs. New users can try for free at Indeed.com/stuff. That's Indeed.com/stuff. Terms, conditions, and quality standards apply.
All right, we're back. We've been talking about the conditions on Venus as we know them today, conditions on Venus in the ancient past, and the big question, was there life on Venus? And is there life on Venus? So we've speculated on the possibility that there could have been life on Venus in its ancient oceans, if they existed. But when we look at the planet today, the surface, again, is just an intolerable hellscape. But when we get up into the clouds, that's where we start seeing conditions that make sense for life as we know it.
Now, to be fair to the surface of Venus, of course, the surface of Venus, like the surface of Earth, is not exactly the same from equator to pole, right?
Yeah, in fact, it has been proposed that Venus might boast acidic polar seas. Back in 1970, Joseph Seckbach and W.F. Libby suggested that photosynthetic life could exist in such an environment based on experiments with algae grown in pure CO2 under pressure with an acidic nutrient medium at elevated temperatures.
And I mean, we've seen extremophile organisms on Earth that survive in highly pressurized environments, in very, very hot environments that live in, say, geysers or around geothermal vents. You know, these are conditions of life that us surface-dwelling landlubbers can't really imagine, but certain single-celled organisms or simpler life forms have evolved to specialize in these types of extreme conditions. They're usually called extremophiles. Now, we don't know if that's actually possible on the surface of Venus. I mean, the surface of Venus is maybe too extreme for even the most extreme extremophile you can imagine. But the tolerances of life, if you expand your definition of life, go far beyond what you might imagine just looking at the life forms that inhabit your nearby forest or looking into a tide pool.
Yeah. I mean, certainly when you start looking at deep hydrothermal vent environments, you start looking at the creatures that thrive there, it does shift your expectations a little. And then also when you get outside of, because when you look at those vents, I think one of the things about deep hydrothermal vent environments that is really captivating is you get to see things like the Hoff crab. You know, it's not really a crab; it's more a variety of lobster. But these pale crustaceans that swarm around these vents, like that captures our imagination because we can look at that and we can say, okay, it's a crab, it's an animal. I can relate to that more. But when you're just breaking it down to microbes and simpler life forms, then it's life, but it's not the kind of life that we necessarily dream about discovering on other worlds.
I'm sorry, I haven't heard your last couple sentences, Robert, because you got me Googling Hoff crabs.
Oh, yeah, the Hoff crabs are incredible. They're these like squat little lobster creatures.
It looks like a mountain of skulls.
They do.
It's like on a mountain of skulls in the Castle of Pain, I sat on a throne of blood.
Yeah, basically. If you look up pictures of these guys, they're jockeying for position in order to get closest to the superheated water. Because that's where they're going to find the little critters that they eat.
This is crazy. I've never seen that. Well, anyway, I'm sorry, but yes, I should acknowledge your point. The more willing we are to think of organisms less and less inherently like us, the farther out into the extremes of physics and of nature that life can extend.
Yeah, as I said earlier, we really have to look at the clouds, the atmosphere of Venus. That is where you can get away from those hellish surface conditions, and you encounter conditions that are far more in line with what we typically think of as life-sustaining conditions. Grinspoon has written a number of papers on this. He points out that there are pockets of Venus that you, quote, can't completely rule out as habitats for life based on what we know, and in particular, the clouds of Venus are really interesting environments because unlike the surface, they are not particularly hot, and they are a continuous and sort of chemically and energetically lively environment in terms of the sort of availability of possible nutrients and availability of energy sources and liquid media and the biogenic elements. And he also pointed out, this I found super interesting, in his 1997 book, Venus Revealed, he proposed that a photosynthetic pigment may serve as the, quote, unknown ultraviolet absorber. And this is what may represent one of four possible signs of life on Venus, along with absorption of solar energy by microorganisms as a driving force for superrotation, the presence of larger and irregularly shaped cloud particles that may be quote-unquote creatures, and the presence of bright radar signatures on the mountaintops, which may be covered with life. So that's another thing to keep in mind when you're talking about the hellish surface of Venus. There are peaks. There are places that are going to be elevated from the truly like pressure cooker environment that you find lower down.
Absolutely. And I think in your talk with Suzanne Smrekar, she also mentioned that the cloud environments of Venus could host microbes, right?
Yeah, yeah.
The interesting thing is, this isn't crazy. Like, we don't often stop to consider this, but here on Earth, life is actually not confined strictly to the surface of the planet and the water that's beneath the oceans. Of course, we know we've got flying birds and so forth, but there's plenty of evidence that if you were to fly up into the clouds and sort of take a bite out of a cloud, you would probably end up with some life forms in your mouth.
Yeah, breathe deep.
Yeah, dirty clouds. There's a great article by Leslie Evans Ogden called Life in the Clouds in the October 2014 issue of Bioscience. This is a fun read, and it talks about clouds full of bacterium called Pseudomonas syringae. It's bacteria that seem to float up into the clouds and perhaps spur ice nucleation, which gives them enough weight to come falling back down to the surface. And the article discusses the idea that microorganisms living in clouds might play a major role in weather and rain cycles on Earth. And this is known as the bioprecipitation theory.
Yeah, people often forget that when you're dealing with drops of precipitation, rain, snow, frost, etc., it has to form around something. It has to condense around something. There has to be a starting point. And that point can be a microbe.
Yeah. And so it's obviously the case that with very light microbes, they can tend to be buoyant within the atmosphere. Like a turbulent air current can churn up a bunch of dust that has microbes living within it.
Right.
And that can get sent up into the atmosphere. And suddenly you are a microorganism that is miles above the ground and you're up here in the cloud. How are you going to get back down to a place that's better for you in terms of reproduction? Because the upper atmosphere of Earth is probably not a good home for microorganisms on a permanent basis, right? High up in the atmosphere, it's often very cold. It can be very dry. You can get desiccated if you're a cellular organism that needs liquid water. And there's exposure to high levels of UV radiation from the sun, which of course can burn your life away.
But it's a great way to get from one place to the other, right? It's kind of like when humans fly up into the upper atmosphere. It's about getting from one point on the surface to another point on the surface.
Yeah, that's actually really interesting. It's been sort of hypothesized that what if air currents, like the jet stream in a way, could function to transport interesting bacterial mutations from one population of bacteria somewhere to another, sort of like a gene conveyor belt.
Yeah.
But even if it is useful for the genetic diversity of a bacterial population around the world like that, microorganisms that travel in the Earth's clouds don't generally want to live there forever. But Venus's atmosphere is actually not the same as Earth's, as we've been discussing. And despite how hostile Venus is in many ways, Venus's atmosphere might be a better place for organisms than Earth's atmosphere. Organisms that might dwell within it, of course, are also different from the organisms that live on Earth and might make their living in a different biochemical way. So, Robert, you mentioned a paper earlier by Sanjay Lamaya et al., the one that's in Astrobiology this year in 2018. And that the earlier thing that we talked about from that paper was the conclusion that Venus might have had oceans for 2 billion years, which would give plenty of time for organisms to possibly evolve there. But the authors of this paper also talk about the possibility that there are organisms living in the clouds of Venus today, just like Grinspoon was talking about. So the authors note that there are lots of good reasons to look for life forms in the lower cloud layer of Venus, which is about 47.5 to 50.5 kilometers from the surface. Now, if you look at this layer of the atmosphere, it's got very moderate temperatures, roughly 60 degrees Celsius, which is about 140 degrees Fahrenheit. It's got moderate pressure. It's like 1 Earth atmosphere, roughly. It's got moderate radiation exposure. They write that the UV levels in the upper atmosphere of Venus are probably similar to the UV levels of the Archean Earth's surface, where, of course, we know microorganisms thrived without being destroyed by radiation. And they mention that it has, quote, micron-sized sulfuric acid aerosols, which are water droplets containing sulfuric acid dispersed throughout the clouds.
Yeah, really, when you think about it, the atmosphere of Venus is kind of it's more like the surface of Earth in many respects, you know, or at least what we think.
But without a ground.
Yes, but really, when you think of Earth, though, think of the fact if you're dealing with the hard surface of Earth, most of the hard surface of Earth is a cold, lightless desert environment that is underneath the ocean.
That's a very good point. Maybe you should think about the atmosphere of Venus being less like the atmosphere of Earth and more like the waters of the oceans on Earth.
Yeah.
But anyway, all of this that we've been saying so far is just to the point that it's not impossible that there could be microorganisms living within the clouds in Venus. You know, there are some favorable conditions. Are there any positive reasons to think that there might be organisms there?
Well, this comes back to the unknown UV absorber that we talked about earlier.
Right. So there's this thing that we have observed embedded within the Venusian clouds.
So LeMay thinks that, there could be alien bacteria in the clouds. And when we're looking at the unknown UV absorber, this could be it. So NASA has studied the unknown UV absorber for some time. Mm-hmm. Basically, we're talking about an atmospheric anomaly where we see UV light being absorbed by something.
Right. In general, Venus is highly reflective. It's a bright planet. Like, it shines things back out into space when the sun shines on it. And the clouds that surround it reflect a lot of sunlight. But there is this weird, mysterious UV absorption thing creating this contrast within the clouds. There are dark patches and patterns within the reflective clouds. And the question is, well, what could that be?
Now, we can say what it almost certainly is not. It's not going to be, say, giant atmospheric like manta rays or anything like that. You know, it's not going to be space whales in the atmosphere of Venus. But it could potentially be like clouds of microorganisms, like colonies of microorganisms, kind of, not to exaggerate it too much, but kind of like the krill of Venus, but with no whales coming around to scoop them up.
No, that's a very, very good point of comparison, actually. People, in fact, the scientists who worked on this have compared it to the way you would look at algal blooms in bodies of water here on Earth. That's a good point of comparison, because one of the most interesting things about these dark patches is that they have this kind of shimmering, moving kind of quality to them. A quote from LeMay, which he gave in a press release, is he said, quote, "Venus shows some episodic dark sulfuric-rich patches which contrasts up to 30 to 40% in the ultraviolet and muted in longer wavelengths. These patches persist for days, changing their shape and contrasts continuously and appear to be scale-dependent." So, yeah, they've got this weird dynamic quality to them, just like a bloom of organisms in ocean water might.
Now, I know some of you are probably remembering, well, you said that there are sulfuric acid clouds up there. How is life thriving up there? Well, one of the points that LeMay makes is that, well, if you consider the fact that life on Earth, as we know it, can thrive in acidic conditions, that it can feed on CO2 and produce sulfuric acid, it all lines up with the environments that we know to exist in the atmosphere of Venus.
Yeah. Now, to be clear, we're not saying that this is evidence that there is definitely, life in the clouds of Venus. It's just that there's a lot of interesting evidence that would line up with there being patches of microorganisms in the clouds of Venus that are making their living this way. Now, there are other options too. It could be chemical, right? Maybe you got patches of sulfur dioxide and iron chloride absorbing UV in the atmosphere, but that doesn't necessarily seem to explain everything we observe, at least not to LeMay and the co-authors. So there are these light-absorbing particles dispersed in clouds, and we don't know for sure what they are. The idea that they're microorganisms is a very elegant and exciting hypothesis, but is there any way we could test this to see if it's true?
There is, and we should note we haven't gotten to test it because anything we've sent through has not had the equipment or it has not spent the necessary amount of time in the atmosphere.
Right.
But there is at least one really awesome proposal for studying the atmosphere of Venus, and it involves
Shatner.
No, it involves vamps.
Vamps?
Yes, and by vamps, I don't mean the space vampires of our favorite Tobe Hooper movie,
Life Force.
Life Force, yes.
Oh, I thought you were going to say Planet of the Vampires.
No, it doesn't involve those space vampires either. Though that is also a good one.
Man, I love Planet of the Vampires. They got the best space suits in that movie.
They do. They're so stylish.
Leather space suits.
But this is pretty stylish too. I think if you'll allow me here to discuss the Venus Atmospheric Maneuverable Platform, or VAMP.
Please do, Robert.
Which is a proposed Northrop Grumman planetary exploration vehicle. And you should look up images of this at home. It looks kind of like a flying wing, which is interesting considering that Northrop Grumman made the original flying wing aircraft, the experimental YB-35 and YB-49, the former with propellers, the latter with jets, from the mid to late 1940s.
I don't think I know what those are. What are they like?
They essentially imagine a big boomerang as a 1940s bomber, and that's what you have with the YB-35 and the YB-49.
So these were military aircraft.
Yes, yeah. They were designed to be big bombers. And Northrop Grumman later came back and did the B-2 Spirit stealth bomber. So if you've seen images of the stealth bomber, then you have seen a flying wing aircraft.
Oh, okay.
Yeah, so they really like the idea of a flying wing, and in fact, the VAMPS concept involves sending one to Venus. So we're talking about a propeller-driven flying wing type craft that's solar-powered and also semi-buoyant. So it's kind of a blimp plane hybrid.
But it's a prop plane in Venus.
Yeah,
right?
yeah, it's a prop plane.
I love this.
I love the idea that one day we could have a propeller-driven vehicle in the atmosphere of Venus. It would have about a 180-foot or 55-meter wingspan. It would fly at a max speed of about 30 meters per second or 67 miles per hour, and that its desired altitude would be something about 50 to 70 kilometers or 30 to 45 miles above the hard surface of the planet.
All right, so that would put it within access to that nice range that LeMaitre and colleagues were talking about.
Right. I should also point out that this is what's categorized as a lifting entry atmospheric flight system, or a LEAF system, which has also been proposed for explorations on Mars and Titan. But here's just a quote from the material that Northrop Grumman has on the VAMP project. The VAMP is, quote, an aeroshell-less hypersonic entry vehicle that transitions to a semi-buoyant, maneuverable, solar-powered air vehicle for flight in Venus's atmosphere. So it's an atmospheric rover, and it could last for up to a year in Venus's atmosphere, just flying through the upper and mid-cloud layers, equipped with atmospheric sampling equipment, including equipment that could help us determine if there are signs of microbial life within the skies of Venus.
Loving this for multiple reasons. Number one, I, of course, always just love good space exploration, and let's look for life. Come on. But on top of that, since it's a prop plane, I'm imagining it's got to also have a surly mechanic with a big wrench sticking out of the overalls that's like working on it.
Yeah, one would imagine. But
kind of yellow and sulfur stained, right?
Yeah, I do have to point out that it's very early days still for VAMP, but it is one of the options that's very much on the table for future exploration of Venus.
I like it, man.
Yeah. And until we send something like there, we can't say for certain when it comes to the question of microbial life in the clouds there.
Well, I guess we'll just have to wait and see. No, wait, we don't have to just wait and see. we can publicly encourage space exploration. Come on now.
Yeah. Now, earlier on, we were talking about the possibility of life in Venus, and you went a step further, and you said, well, what about intelligent life?
Now, I know that's kind of hard to imagine because let's say, according to these predictions based on the papers we've been talking about today, that maybe Venus had oceans for 2 billion years before the runaway greenhouse effect killed all that. We know from experience in the history of the Earth that 2 billion years of access to oceans is not enough time to evolve complex multicellular organisms with brains and the ability to build civilizations and all that. But let's just imagine things went different there. For some reason, maybe evolution happened faster. We don't know. What would things be like if, say, you have an intelligent civilization on a planet, maybe at the level of technological achievement that human civilization is at right now, and you realize all your scientists tell you, oh, okay, we've got runaway greenhouse effect going on. We've got a couple hundred years before things get intolerable on the surface of this planet. What are you going to do? And I wonder, well, what could be done? I mean, is that just definitely the end for the species, or can you somehow try to come up with some sustainable way to retreat to the subterranean realm? Can you get geothermal power? I don't know, making light bulbs for you to grow plants down there. I just wonder what's possible. How long can you survive on a planet that doesn't want to host life on its surface anymore?
Oh wow! I mean, well, this is a wonderful sci-fi question. And in fact, you have some fairly old works that kind of explore it a bit. The old William Hope Hodgson book, The Nightlands.
Oh, I haven't read that. What is that?
It's tremendous work of early, essentially post-apocalyptic literature, in which the Earth is grown dark. It's the Nightlands now, and there's this place called the Last Redoubt, and so it's like a pyramid, an artificial structure created by humans, and it's powered by hydrothermal power. And this is where essentially the last remnants of humanity have assembled themselves and tried to sort of hold on to life against the darkness and the cold.
Sounds bleak, Robert.
It's pretty bleak. It's kind of gorgeous in its own way, but we're talking about a bleak concept.
Yeah,
we're talking
that's true.
about
Yeah.
a life form losing its environment and having to adapt to some sort of new take on life, either by retreating into the darkness or finding a way to live up in the clouds.
Yeah, and then, of course, this is premised on the idea that if the scientists of Venusian civilization did come to them and say, look, we've only got a couple hundred years before it's too hot to live on this planet anymore, would people actually pay attention to them and do anything?
Right. It would kind of depend on what's the lifespan of the Venusian beings here. If it's like humans, then when you tell a human, all right, we need to do something because something bad happens in 200 years, they're going to say, well, I'm not going to be alive for that.
Right.
What's happening tomorrow? What's happening the week after next? What's happening maybe next year? Because we as a species don't have a great track record for long-term planning.
Right.
We can maybe think into the next generation if we're being generous. So I don't think the human model leaves much hope for what a Venusian life form might have accomplished.
Yeah, you can imagine there was a lot of, these, runaway greenhouse effect alarmists.
Yeah, or 200 years. Well, the next generation, they'll figure it out. Yeah, the technology will come online and they'll just fix everything. And while they're all chatting about it, the oceans boil away, and then they boil away as well. But maybe a few are able to crawl down into their crypts. Maybe a few are able to make it up into their cloud cities. I don't know. If they can keep the others from dragging them out or dragging them back down.
I guess this maybe deserves a whole episode someday. We should come back and examine the idea of how long could say an ecosystem be maintained purely in a subterranean existence? Could you go on indefinitely if you had incoming energy sources?
Yeah, I love talking about subterranean life, so that would be a great topic to discuss. In the meantime, we thank everybody for joining us on this trip to Venus. And if you enjoyed this episode, let us know. Let us know what other planets, so what other moons even you would like us to explore in future episodes. You can check out all of our past episodes at stufftoblowyourmind.com. That's the mothership. That's where you'll find links out to our various social media accounts. And I also want to remind everyone that if you want to support the show, a great way to do it is to rate and review us wherever you have the power to do so.
Huge thanks, as always, to our excellent audio producers, Alex Williams and Tari Harrison. If you want to get in touch with us directly to suggest a topic for future episodes, to let us know what you thought about this episode or any other, or just to say hi, let us know who you are, where you listen to the show from, what you like about it, you can email us at blowthemind@howstuffworks.com.
For more on this and thousands of other topics, visit howstuffworks.com.
When you're hiring, you don't want to waste time. You want an efficient way to get to your short list of qualified candidates. That's why you need Indeed.com, used by over 3 million businesses. Post a job in minutes, set up screener questions, then zero in on qualified candidates using an intuitive online dashboard.
And when you need to hire fast, accelerate your results with sponsored jobs. New users can try for free at Indeed.com/stuff. That's Indeed.com/stuff. Terms, conditions, and quality standards apply.